informal talk, and we can discuss further, right? So don't think that it is up to the Gyan program and all. If you have any questions, so when I say any question means literally any question related to your career, related to your even life, related to anything, just tell me that what is the problem, we'll try to solve it, right? So don't think that it is, treat me more of your friend rather than faculty. That's what I used to tell to my students. If you treat me as a faculty, you might, see a barrier and then, okay, should I ask, should not ask. Feel free, I'm just like you. Just I was there 10 years before, now I'm here. Maybe you will be here 10 years after. So it's just a matter of time, everybody's same, right? So with that note, I will start the study, and it's a quite interesting study. You will see it took us a lot of time to do that, and pretty interesting one. And then we'll go for a tea and we can discuss more before we start the validator. Okay, so this you have seen yesterday. I'll just go to the, okay. So before I start this, I just want to give you a background on that. So actually, as I told you, whenever the prosthetic limb is used to grasp any object or any kind of daily life activity, most of the time that this is expected that the feedback of using that device will go to the amputee, and he will like use that information and he will do that. This is kind of a very interesting study which is from my stay in Singapore at NUS before I joined Mike in US. In fact, before that I was in UK, so this is like the first study when I moved out of IIT Delhi. So this is a very different story. And this came from an idea when we were visiting some hospitals in NUS. So there is a kind of disease that is called leprosy, right? You heard of this? Okay. So it is said that if leprosy patients are treated in a very nice way or maybe by human touch, their recovery is very fast. But unfortunately, nobody wants to actually touch those patients because of many reasons, I don't want to discuss, right? So what we thought that time is it possible that we have a robot? Let's say there are some leprosy patients and there are some robots, and I command those robots through web server, which you call now IoT, and whenever they need kind of hug, they need a kind of social touch, that robot touches them, and they feel like some human body has touched them. Because there were enough evidence that if they are being treated nicely, you might have heard of this Mother Teresa hospital in Calcutta, where a lot of nuns, but these nuns are really God figure. They have a lot of patients to do that. Otherwise, it's very difficult to do this. So we thought, let's have a robotic kind of hand, which can be like adjacent to the any bed, and whenever they need it, I will send a command based on server, and then server will move that hand, and they will feel like bed. Looks like a very simple experiment, but has a lot of impact, right? So we did this. In fact, I did not do it. There was an undergrad student in our lab at Singapore. He did it. He just showed the prototype. Yes, it worked. All technical, no science. Then my advisor there in NUS, he asked, Deepak, can we plan something like this, that a hand being touched to the other person, whether it is prosthetic or what, feels like a human hand. So are you getting this point? This is a kind of a different story. Before all these lectures, we were on this side of the research. Now on this side of research, right? Now we don't want a prosthetic hand which is very good in functionality, or we want that if I handshake you, you should not be able to judge me that I have artificial hand. So I want to make your brain full in such a way that the brain receives the same physiology as of the natural human hand. Is the problem clear to you? Right? You will not believe that across the globe, 50% of people does not wear the upper limb prosthetic just because they are not socially accepted. Functionality wise, you have very good prosthetic hands, but whenever they handshake with somebody with that hand, somebody will immediately realize that, oh, he does not have a natural hand, he's wearing a prosthetic hand, he's an amputee. So that being considered as an amputee is a big social stigma for the people around. They don't want to wear because they feel that they will be noticed as an amputee. So that's where our research came into the picture. We decided, can we make a hand which is being receptive as a human hand to any other people? Right? So problem is clear? Okay, let's see how we do that. So the idea was illusion sense of human touch from a warm and soft artificial hand. So let us discuss it later. What do I mean with that? But the specific research question was, can the touch from an artificial hand be perceived by another person as if the touch was coming from human hand. Right? Looks like a simple problem, but I'm telling you that any government is funding enough to actually solve this problem. Because the problem is, because fortunately God has given us a very nice body, very functional body, so we don't pay attention to all these small things. But you won't understand that these small thing in somebody's life is so frustrating, right? Okay, so let me just go to the brief background. So our hand is basically, right, very interesting anatomy. It can be as hard as possible, right? It can be as soft as possible, right? It conforms to the shape of the object. I can pick the pen, I can pick the ball, I can pick the bottle, right? So it has very remarkable properties, like easily deforms with the slight contact, stiffness with large contact force, conforms to various shape of the objects, touch against external elements, soft enough to provide comfort touch. So the challenge is to create a hand like that. It's really a challenge. Such a remarkable property in some artificial things is not easy, right? So, and the touch is very important, right? You can see patting a baby, right? Hugging somebody, handshake is like a common gesture you do almost in the everyday life, right? So the importance is there. The importance is there, right? So I will. That's why I said in the first lecture, maybe or yesterday or tomorrow, I'll show you that there are enough proof that people actually don't wear this prosthetic hand because of this reason. Alters personal social life. They don't want to go to any gathering. They don't want to go to any meetings and all this, because you will be like socially, noticeable. I mean, I remember, like, this is a big thing. I remember my sister when we were quite young. Whenever we used to go to any parties, she will say, "Oh, I have a pimple here. How can I go to this party?" And say, just a small pimple. Just imagine somebody's life is like out of track, and you expect him to go to the a big gathering. Everybody will notice, and once you become a attention, you feel very frustrating, very depressed. So for you, it might look simple, but for somebody, it's like life-changing kind of thing, right? So the quality of social interaction also decreases. They don't want to interact much. They don't want to come out of the family. Even though somebody would like to help you, but they will feel that he's helping you because I am in this situation. That is another social factor, right? So we thought, okay, let's try this. Does the touch loss cause social stigma to amputee? This was a research question which somebody answered through a lot of surveys across the globe, and he came with these two. Yes, this touch actually creates a lot of social stigma to the amputee population. How? They alters the social life of the person, and the quality of social interaction actually reduces drastically, right? Okay. Now, what we want to do is whether an artificial hand would feel realistic to the person being touched. That is the overall goal. If we can do that, it's a wonder. Somebody's life, you have created a lot of comfort to somebody's life. You have created a lot of motivation to somebody's life, right? So we answered this question in a very fantastic way, and it was one of the most popular article at that point of time. I'll show you at the end. We conducted following experiment in the 3 steps to answer this question. First, perception experiments with artificial skin samples, lifelike artificial hand, and then perception experiment. So let me go one by one. That will be easy to understand. Okay. So what we did first was, there were a lot of robotic hands in the market with various materials. So what we did, we chose 2 materials from there and 2 based on some physiological experiments. And what we did was, we made a small finger-like this sample like this. Can you see this? Inside this, there is a micro heater. Can you see the micro heater? And at the top, there is a temperature sensor. Right? So what happens is, this is a kind of assembly which then we put on this big board. So in this board, you can see that 4 samples this side, 4 samples this side. So in this side, the softness is increasing, softness of the hand, of the sample. And in this side, the temperature is increasing. Right? And what we did was, we asked almost 165 participants. And luckily in Singapore, you will find like ethnicity is very high. You'll find people from Australia, you'll find people from China, you'll find people, because that is also one of the factors of the skin, which is very important. Yesterday we were discussing in your lab. You remember when Mike was saying that across the ethnicity, the skin sample actually changes. So luckily in Singapore, we were like having a lot of variety samples. So we are from India, Australia, even US, South Africa. So we asked almost And we ask the participant, so these are the four materials and they are the manufacturer. And this is the sold durometer. This is a kind of instrument which measures the softness of a material. And we enhanced in such a way, and we call the participant, and it was done in a controlled environment, and the temperature is controlled, and we ask the participant, which were female as well as male. We made sure that there is no biasness of gender or ethnicity. We ask them, okay, touch any one of them hand. In fact, you touch anybody of the hand, anybody of the sample, and then you tell us which one you feel is more closer to the human hand, right? So what happened, and remember, so this temperature, which is at the skin surface, is being controlled by a microprocessor or whatever the microcontroller say, based on this heater. So controlling the temperature by this heater is not an easy job. You might feel Arduino may just write a threshold program that if it is more than 20, do it, more than less than, you can't do this. You know why? Because there is always a residual heat. You will cut off at some point of time, 27 degrees, but the heater will not immediately go up. So heater will go off after a certain time because of the inductive phenomena. So still you will feel that I have cut off, means it should be 27, it won't be 27, it will be 28. And moreover that, to add to the challenges on that, when you touch that finger, which is at 28 or 27, it will not remain 27, 28. Why? Yes, heat transfer will take place. So these experiments looks easy, but they are not easy. That's why Mike also told. In paper, you don't write everything. You have to read between the lines in the manuscripts. It is 6-month job, and somebody asked me that, can you write in 6 pages? Do you think I can write everything? And what we do, we just copy from that existing paper, replicate, and we say, yeah, we are done. We have done the same thing. I don't know why it's not my coming. I did exactly the same thing. But buddy, you missed between the lines. That is a problem, right? So for example, in this case, what happens is, whenever you touch that finger, there is a heat transfer takes place due to convection. And when this heat transfer takes place, until unless there is equilibrium temperature of human body as well as the skin, it will continue. And then how to calculate the interface temperature is by this equation. I don't know how many of you actually this equation. And this equation is only applicable when you apply, when this equation is only applicable when this material and this system actually qualifies for the Fourier number, which is given by this. So do you know how complicated it is? Just to calculate one temperature, I need to do this much of mathematics. But if you do it, you have a very high chance that you will be accepted by the reviewer, because he understands that you have done very nicely all these small things, right? You might even, like, I mean, don't take me otherwise, but I'm telling you, if somebody would have done it in India, you would just put in the RDO, oh, cut off 27 degree. Okay, I did this experiment, same experiment, they also did, but they are not accepting my manuscript. I don't know why. Because first thing, your idea is not novel, you copied it from somewhere. Second thing, you did not actually do it nicely. You missed many finer details. Whenever you are doing research, you need to go into the details. Unfortunately, many people which I review from India, they are very superficial, very superficial. If you little bit ask more about the details, they will say, no, we did not do it. So anyways, so that's a different part of the story. So what we did is, we calculated this temperature and all, and what we found is that the existing temperature of 27, and with this softness, so basically this is the material type and this is the initial surface temperature. So we found that most of the people appreciated that this particular bar, which is corresponding to material A and 27 degree, is basically the most closer to the human hand as a skin sample. And what we found is, what they are saying 27 temperature is not actually the 27, it is 28.4 based on this equation. Understand? Right? Because if I make 27, that will be a wrong decision. You got the point? So we found that, okay, this is kind of the temperature which people are mostly preferring for as a human skin, this material with this temperature. Okay, this is a part 1 of experiment, so keep it at the back of your mind. We'll come back to this. Now, the second question arises is, because my hand has bone also, so whether in the artificial hand, whether I should keep the bone or whether I should not, right? So that was kind of another question we have to answer. Then again, for that we have to spend 1.5 months to exactly see whether we should do it or not. So what we did is, we created a human hand. I mean, this is of course the human hand, and we created a hand with the bone and other hand without the bone from the material which was selected from the previous experiment, right? One with bone, one without bone. Got it? Okay. Now, how do we create that? Because that's what I'm saying. Small things, but you have to do very small things, but impact your paper like anything. Don't be superficial. Do small things, but do it so correctly, so nicely that everybody understands. This is the best package for this study. Nothing can be better than this. So then the next question are, what should be the dimension of the hand? So somehow we read an article and we found that this, somebody has that research. We did not do that research, but we found that 50 percentile of the population across the globe has this much of hand dimension at the adult age. So luckily we found a person who was matching exactly the same dimension. Then do you know what we did? We took a CT scan of that head because we wanted to know where to place the bones. You can't place anywhere. So this study is not to actually impress you. This is to make you understand that even small things matter. Just small things matter as well. So you don't have to do big things. Do small things, but do it so nicely that people think that this is the best package for this study. Nobody else can do better. And I will show you that what comments actually reviewers gave us, and that too from IEEE itself. They said this is like unbelievable story. This is wonderful. And in the first go, the paper was accepted. Anyways, I'll come to that later. We took the CT scan, this is CT scan image, and then we created an artificial hand with bones. So we created two hands, one with bones, one without bones, right? And with the temperature which we got from with the skin material which we got in the previous experiment. Now what we did was, when we created this hand, this is a robot, indentation robot. Do you heard of this robot? It's a very interesting robot. It's very simple. Maybe mechanical people will know it. So it's kind of what it does is, so there is you can see this knob, right? So when it dips in your skin, so based on how much it could, because there is a force coming, and based on how much you dip, it created a softness map of the hand, right? So what we did for the human hand, we created a softness map. For the hand without bone, we created a softness map, and with the bone, we created a softness map, right? So now, what do you think? Among which group out of these three will have a significant difference? What is your hypothesis? If I don't do this experiment, I don't have results. What do you think? Out of three, one is human hand, one is artificial human hand with bone, one is human artificial hand without bone. Human hand? No, we are not talking of fluids. Like, we have only three conditions: human hand, artificial human hand with bone, artificial human hand without bone. So which one do you think is very close? With bone or without bone? Without bone? With bone. Very simple. Why? Human hand has bones, right? But we just wanted to do this experiment to make sure that we are not doing anything wrong in this entire journey. Because if you don't do this and reviewer comes back after 2 months and says, how do you know that human bone will, that without bone will be better or with bone will be better? So you have to make your study entirely foolproof. No chances of going back. So we just did it, and what we found is, you can see this graph. So unfortunately, it is not that clear here, but you can see this one is basically the one that is human hand is this one, and this is the hand with bone. This one is the without bone. So you can see here, first two are always very close, right? So you have to do it. That is the point in the research. You have to do. Until unless you don't do, you can't claim anything. You can't even claim that water has this much of temperature. You have to do measurement, you have to do the analysis, then you report it. This happens in my lab mostly, and I am very much frustrated about that. Most of my students, they have a lot of good ideas, but they don't want to jump into the water. They always do research in their mind. This will happen, then this will happen. But until unless you go there, you can't say what will happen. You have to dive into ocean, then come back, okay, this happened, and then make a case study to submit a manuscript. Just sitting outside and then saying, this will happen, this will happen. This won't work. You have to do the experiment, you have to conclude the results. Maybe it's a failure experiment. How does it matter? But that failure will lead to some success in future. Right? So this, what we found was of course a very, very obvious hypothesis, right? Like you said. Bone will be, the hand with bone will be more closer to the human hand. But we just thought, let us do that and find out whether actually it happens or not. So when we did this is a softness map you can see of these three hands. So you can see the bones here. Can you see the bones at the end of this? And this is without bone, and this is the human hand. So when we did this, we found this. What we did next was very interesting. Now we created two hands. What are these two hands? No. What? With? No. In the first two experiments, what do you conclude from the first experiment? Temperature is a very important component. What do you conclude from the second experiment? Bones are important. Now we created two hands. Bones with temperature, bones without temperature. Because without bone has no logic. We have seen in the second experiment. It's nowhere logically. I mean, forget that what the participant will say. Even the physiologist says it is not close to human hand. So we rejected that. But in the first one, we don't know because we have not conducted that experiment. I cannot conclude based on the two experiments that this will happen. I have to do another experiment. Now we created two more hands. Both hands are having bones, but one is without temperature, one is with temperature. Right? And one is, of course, the human hand. And this is a very nice experimental setup. So just to do this setup, it takes 1 month. Just to do this. It looks very simple, right? But I'm telling you, it took me and one of the MTech students at NUS entire 6 months. And she was so hardworking, better than me. But still, it took just 1 month to make this setup. So this setup is very interesting. What we want to do here, you can see the computer screen. In the computer screen, there are options 1, 2, 3, 4, 5. One thing, right? And this lady, or this time it is a lady participant, but we have this male also. So she cannot see from this part. It's opaque. She cannot see what is going on this side. And she is also wearing in this, you may not see, but can you see this? Earphone. Do you know what is the role of that? And what kind of noise will play there? White noise. You can YouTube, you just say, I want to play white noise, they will play white noise. Just to ensure that that's what I'm saying. You will say that, is it really needed? It's not about whether it's needed or not. It is about making the foolproof experiment. No chances of failure. Right? Just imagine, like recently we failed in a Chandrayaan experiment. Just imagine like 8 or 9 months of journey and suddenly you fail. So you do your best not to fail. You might fail, that's a different story, but do your best not to fail. So even though I'm very sure, even if I would have put or not, won't hardly affect my results. But just to ensure, to say that we did our best to ensure that participant only is focused on this, we did this. So there is a earphone. Oops, sorry. Yeah. So the participant is having this earphone, this experiment. Now, these three hands will be touched randomly on this part. And the participant does not know which hand. So it can be human hand, it can be human hand, artificial hand with bones and temperature, artificial hand only with bones with no temperature. Right? And participant has to answer from 1 to 5 that which one of them, like how do you rate this hand? Because she cannot see it, she has to respond on the computer screen like 5. Very likely to be human hand, very likely to be the prosthetic, very likely, or maybe somewhere in between. And what do you expect the results? I mean, not expect. What is your expectation? What do you wish? What do you wish? So ideally, I wish to God that participant always says that human hand with bones, with temperature, says that it's a human hand. That's what the objective of the experiment is. That's how you can make your brain full. Somebody's brain full, that it is not an artificial hand, it's a real hand. Right? And luckily it happened because our experiments were very nicely designed. That is why it happened. So you see, when we ask the participants, so these three hands, human hand means actual human hand. So I was the experimenter, so I will touch it. Right? And then cold hand. Cold hand means hand with bones, but no temperature. And third one is the warm, this hand. You can see the temperatures, micro heaters. So micro heaters are going inside the entire hand. And then when we did this experiment, what we found is out of 196 times. So if you see this figure, in the human hand, out of 196, this is the total 196 actually. So among the total one, they were, if you combine this number, 65 and 51, certain to be human, very certain to be human. So we can assume that both are same responses because human does not have ability to discriminate between 4 and 5 for a given response, right? And if you see this one, 45 and 45, 90. What we and if you see the very certain to be human figure, very certain to be human, it is 51, it is 45, almost as they expected in the real human hand. 45, 51, not much difference, and that figure is from 165 participants, right? So this study was covered by BBC. You know why? Because this was the first study who took into the consideration of social part of the activity. Everybody is talking of machine learning, everybody is talking of signal processing, everybody is thinking how to make prosthetics more intelligent, more adaptive, more terrain wise, less power consumption, but nobody thought how the amputee is feeling. So we actually decided to, okay, and that's what the comment reviewers gave us. This is remarkable. And he also said, he was, I don't know, they don't disclose the reviewer's name, but he said, entire 30 years of career, I did not see any paper like this to review. And he wrote that he feels himself very lucky that he reviewed this paper, and that too from IEEE, because this was a very interesting story. Interesting in the sense that we could actually see that what are the emotions of the amputee, what does he actually want. Everybody is running for signal processing, machine learning, but what the amputee want? Does he really want this kind of signal processing and machine learning? He may want functionality, I'm not ignoring that. But what does he actually want? He wants that he can be socially acceptable. Right? So this is what we concluded from this study. I mean, I have a very interesting video, but I don't know if it is not playing here. Yeah, sorry. So then our results suggest that a soft rubber material with warm skin surface temperature is critical for the artificial skin to be perceived as lifelike. And an illusion of human touch can be created from an artificial hand with embedded heaters. So these are very micro kind of heaters on soft synthetic skin and skeleton structure. And again, this was among one of the very popular articles in that time, this illusory sense of, yeah. So this is kind of a very interesting study. And as I said, this is almost 8 months of job for me, along with my team. And I wrapped up in just, say, half an hour. So you can think of how much I skipped. Okay. So if anybody has any question, we can discuss. Okay, sorry. One thing which was very important, I skipped it. Sorry, missed it, not skipped. So remember, there was a big problem in this, because physiologically, when you touch with a higher pressure, the temperature also changes, and the perceiveness also changes. So I cannot show it here, but just below this hand, between this hand and this hand, there is a force sensor, which is not being displayed to the amputee, but for me as an experimenter. So I put that and I played it in the real time, and I make sure that there is a threshold that this participant has been touched with this level. So all the hands should reach only up to this pressure. Because if I cross that, the participant may have a bias. Always he's pushing this hand with more pressure, because our skins are very sensitive for that. So that is what you need to do. Do everything very nicely, foolproof, no error. So we had a temperature kind of, which participant cannot see, but because I am on this side of this mirror, there is a screen with me in my hand, and whenever I am touching, it is like this. I am touching like this, and I am seeing. So whenever it reaches to threshold, I will stop. I will hold my hand like this, so that there is the outcome is just because of my hypothesis. Otherwise, reviewer can come and say, "Hey, maybe possible that you put it with a more pressure, and that's why you could feel that it is a human hand." Then you cannot run this entire study again. So you have to discuss as much as possible and be open to criticism. If somebody is criticizing you positively, welcome it. Because it's not only my thought, it's my entire team thought. Let's do this, let's do this. The reviewer can ask this question, or participant can bias because of this. So can we do this? Can we plan it like this? So every small things you have to take care of. So just imagine like this entire, developing a hand, doing this entire first experiment, then second experiment, then making a hand, then doing this hardware, everything, and then actually writing the manuscript and everything. It's almost one year. But then in 1 year, you feel really proud when you receive the comments like that, that in 30 years of experience in US, nobody could see this kind of a study to be. Right? So yeah, that's one of the important points which I actually missed. So yeah, please go ahead with your question.
Sir, did you go with the stem cells approach?
Which approach?
Stem cells.
No, not it. I mean, again, okay. So let me get back to this point again. We have to be very practical. There are two kinds of research, and in my lab, I always make a balance between them. One is you want to publish in high journals like Nature, IEEE's, and one you really want to help the society. Right? If I want to help the society, I can't publish, and if I publish, I can't help the society. So every student, I always give two problems. This is for the society. This is for your career. Right? So stem cell. If I wait for the stem cell, MPT won't feel advantage of this. Maybe stem cell can be a good paper to publish. Like I told you, I could have provided the feedback by doing a surgery and providing the feedback on the residual part rather than on the surface. And in fact, we are doing it on the animals in games. But that is just for my publication. Am I really helping the society? But for this experiment, what I did when I did it on the surface, the system is ready, company is ready to take over, everything is ready, and maybe in 1 year it will be in market and everybody will get benefit out of that, especially the elderly. Elderly has told me especially that they are feeling their muscle strength has increased after this vibrotech time because they are able to move little forward. So you have to make a balance. You have to increase your CV, of course, but then you have to make sure that you are helping the society as well.
Sir, for creating the artificial hand, which female hand do you consider or male hand you consider, sir?
So what we did was there was a paper. Actually, we were also confused that what should be the dimension of the hand because this was a very big question to us. So what we did, fortunately, I think there was a survey paper, very old survey paper that helps a lot. There was some certain dimension given in there, and they said that 50 percentile of the human hand dimensions matches to this one. So we exactly tried to find out in our university that whose hand actually matches to that one because we wanted to have CT scan of that. So luckily we found almost like 8 to 10, which were exactly on because we have to make sure that it covers the US also, it covers the India, it covers all the countries. So we found a human hand dimension in that paper, but we are not very sure we can found it in the male or female. So what we did was we actually conducted a survey, and every participant was given like almost 10 US Singapore dollar for that. And they will come and they will give us the dimension, and we'll match. My students will match their this, and they came up after almost 1 month of survey. So there are 10 hands which are very close to this what is given in the paper. Then I think randomly we select anyone who was volunteered to give the CT scan. Then we took the CT scan and then fabricated this kind of hand. The dimension was very important because dimensions are important because you have to fit the bones. Yeah, no, this was not for that person, for sure. But we got the idea from them. So, yeah.
The property of bone is very unique. We cannot find any antibody to impact that.
Yeah. So that's right. So this is a very good question, and that's why we skipped it. So I can refer you to that paper. What he's saying is very good. Like we did not. That's what I'm saying. You can't say everything in the paper because you have to write in 8 to 10 pages. One of the member in the group was mechanical engineer, and he actually devised the bone, and he also did because I am from electrical, so I showed you the electrical part. But he also made sure that the bone, whatever possible, when close to that feature, he actually developed some bone. He and one of the other family. So they created a kind of bony structure hand, which was very similar to that the natural bone, but exactly not like the natural bone. So this has a lot of components. I did miss many of them because of like time as well as I don't know all of these things because mechanical is not my expertise. But yeah, a little bit I showed you that how did we work on this. Any more questions? Good. So if you have any other further question, we can discuss. I think because we have at least 20 minutes for the tea. I finished it quite early. So you can ask me if you have any questions because at least we have to spend 20 minutes. Okay, so what happened is immediately we published this study and BBC covered our article. A lot of company actually approached us, but by the time I moved to UK, so that was a big sort of trauma for me to know that my supervisor actually sold it without telling me. I don't know who is making. I did not get a single penny out of that. But this happens in US, I mean abroad. So you have to make sure that your idea is actually patented, and you get, because as an Indian, I know many of the people, we are very soft. We are not very professional. We need to take care of that. I'm learning it now, but earlier I don't used to like. Okay, I have, God has given me some good things like good brain and all things. Let me do for a people, but don't do this. Never do this, because you need to earn money. Those days are gone when people used to say, think that professor means he will wear a very normal shirt, normal this, he will have a small house, a small scooty. I don't believe on that. I believe a professor should have a very big bungalow, he should have a very big car. If I have a brain, why should not earn money out of that? Not illegally, legally, but you should earn. Like, don't go with that previous kind of things. I recently sold a prosthetic leg in the market for 12 lakh rupees. And I was very happy that I got 12 lakh, that too in India. So don't like. Also, I was having this philosophy earlier that professor means you should be calm, not very high fi. You should be like normal. You have to look like no, it's not like. You should be like whatever you want. Earn money, have a big bungalow, go US, enjoy your money, all this. So you should do that. So these days are gone when people used to think like professors means you have to be like cool, calm kind of thing. So I don't believe in that. So I used to make sure that whenever I have an idea, I have a prototype. So right now I am like almost having 3 patents after coming to India, and all of them are so good. I am very sure that once we release something out of that, anybody will give me. You won't believe, I'm just not exaggerating, but after I earned this 12 lakh from this prosthetic, here is a guy who called me in from Delhi only, and he came to my office and he said, I didn't know that you are making this, otherwise I could have buy this and I would have given you more money. I said, yeah, that's okay. I'm sorry, I did not know that you are interested. Then he said, what are you working on? So one of my PhD student who was there yesterday in that video, he's working for a spinal cord injury patient, trying to decode that how. So we are trying to control the wheelchair by intuitive thoughts rather than making a lot of electronics. So you won't believe, he was in my office and he said, whenever this happens, please let me know, please let me know. I said, he just recruited as a patient, PhD student, and he may take like, and even I decided, we don't know after 5 years it is a failure or success. You won't believe, he immediately took out the checkbook from his bag and he said, I'll sign it here, you put whatever amount, but make sure I get it whenever you develop it. I told him it's not like in IIT. We are employed here, so you have to come through IIT channel and whatever, like the procedure you have to follow. So things have changed a lot. Things have changed. People are moving from papers to the devices so that they can earn money. And to be very honest, there is no harm in earning the money, but if you are doing it legally. If you have given a good brain, you have certain expertise, why not to earn money?
I have a general question. Like you have traveled from UK to US.
Can give you my thing.
You have traveled from generalized question that you have traveled from like Singapore, US, UK. So, what are the general prospects of research as such
Oh.
regarding this biomedical field in
See,
any of the countries or even considering India?
I'll tell you a very general philosophy. It's not only about biomedical. I can definitely tell you one thing which somebody may feel offended or not. Is the teaching in India is very poor. We don't teach students the way should be teach. They should be teaching. Unfortunately, by the time you graduate, your fundamentals are so poor that you feel that you can't do anything. In US, the teaching is very good. They make a student independent from the beginning. Right? At least in IIT, I know that teaching is still much better, and people respect IIT teaching. Teaching is like, that's why they respect it, because they know that people teach very well there. I have only one mouth and one brain, but I wish, given the opportunity, I would like to make sure that we have a big audience, everybody from any college, and we teach, and everybody grasps the same thing which IIT student is getting. Because I believe that this makes a lot of difference. If your fundamentals are very sound, even if it is a US professor, you can argue with him like anybody. And I used to do that. A lot of times with Mike and me, like we used to have a debate on many things. And most of the times, to be very sure, even if he was there, I would have said that he will accept that what I am saying is correct. Right? So we have a very good brain, but our training is very bad training. I mean, whenever they will sometimes invite me some school to give prize to the kids, and I feel students are very good. They are not bad. But by the time they do their 10th, 11th, 12th, or whatever BTech certificate, it's like the teacher will actually corrupt his brain. So the teaching has to be improved a lot. I don't know. We don't have a monitoring system for that, but it has to be improved. Teachers really need to do good hard work to make sure that students are very good. And if you see, I mean, I'm not again comparing. Don't feel offended, but my master's student or BTech students in IIT, they are wonders. I just have to tell them do this. That's it. They do better than my expectations because the training has been so good. The training is so good. Training is very important. Your fundamentals should be very clear, transparent. You know less thing, but you know whatever you are the best. So if I say prosthetics, I would say, hey, this is the best guy in the prosthetics. Maybe you don't know then civil engineering. Let it be okay. But then if you know something, you should know the best. So my experience, like your question, like I traveled many countries. My experience is Indian brain, no comparison. Best brain coming from India, like. But then our training is a bit weaker, and our scientific communication is also very weaker. But in terms of fundamentals of brain, I can assure you, we are the best. Even in NUS, I was talking of that girl. She's from Tamil Nadu only. Her name was Archana, some very typical South Indian name. I forgot. Her name was very difficult to pronounce. So she was doing masters there. I think she's doing PhD now. But she was very like hardworking, very intelligent girl. She has contributed a lot in this project. So we are very best, no doubt on that. But the training has to be improved, definitely. And you don't have to improve, rather the faculty has to improve, honestly, to give really good teaching to the students. So hardly matters you are in US or in India. I even used to tell my master's student that we train them for 2 years so nicely. I mean, everybody in IIT is doing a lot of good teaching, a lot of good research, and projects are very nice. Students are involved. But eventually, by the end of their MTech, they are really mature to help us in the real research. They leave to US, which is very bad. I mean, they are here. I can tell them right now. And I used to tell, we grow the seed here, but you give the fruits to US. So that is something very. I mean, if you give fruits there, let us say you go to Mike tomorrow. You go with Mike for your PhD. You will publish there. Where is IIT? You will say that I am from University of Oregon. People will say University of Oregon. Although we trained you for to deliver that fruit, but eventually what happened? Fruit was given to the US, and that seed actually all the hard work was done by IIT. But you can't stop. Only I think out of 100 on the. So that is, I used to tell my students, my bread and butter is not teaching and research. Sorry, my this all is not my bread and butter. I used to get it from my teaching and research, but I feel rewarded if I can stop at least 10 students voluntarily to stay in India and do research after their MTech. That will be my real recognition. I don't want any award or anything. But if I can motivate 10 students in IIT to stop in IIT and continue the research and prove to US that we are as equal as you are, there is no difference. Even we are better than you. But unfortunately, the problem happens like this. We train the student, he leaves, we have no choice, then an average student comes. And it's not that he is average, he's also good, but his training has not been done in that way. So then we have to again compromise and give him a problem which we feel, okay, he and she can finish in 2 or 3 years or 4 years. So are you getting to where is the problem? We trained them for 2 years, and they were really mature by the 2 years. They know everything, they know all fundamentals, they know how to deliver research, and they deliver it when they go in US, and US gets the recognition. They feel that US is doing very good research. And what happens because they leave us, I will have some average students coming from a different college, which I am saying average not because he is average, but his training is very average. And when he comes to me, I feel his fundamentals are so poor, his writing skill is so poor, his delivery is so poor, so what to do? Then I can't give him a very challenging problem. Then I will give him a problem which is like, okay. And then somebody from US will say, oh, Indian people, they don't publish very well. So this is a true story, very unfortunate story, but this is true story. So that is what I want. I'm not stopping MTech students or BTech students in IIT not to go abroad. What I want to make sure they are filled with the right talent. Once they leave, we can have from other colleges which is equally good, and then we say, okay, you continue. So this is something we see.
Sir, on that same topic, I completely agree with you what you said. But is it like, would it be not okay if we are not having training over here? We go train ourselves over there and then again come back over here and then carry forward what you were trying to say and not let US bear the fruit.
No, I agree to you, but I don't know. Indian government has to think over that. I mean, like, I still believe that uh, everywhere the teaching should be very, very good. Whether it is labs or teaching, but it should be very, very nice across the country. The reason for that is, of course, we can't stop. If somebody wants to go to abroad, we can't stop. If he stops, and with my words, I will feel, as I said, that's not my bread and butter. I used to get it from my research and my teaching. But the real award for me is if I can stop at least 10 bright students in the country to stay here and continue their research. But I don't know, somebody will stop or not. But to your point, to be very honest, I don't know it's possible or not to give equal kind of education or same quality education to everybody in all the colleges. But if somebody has a mechanism and somebody wants to take the lead, I will be very happy. Any further questions? Yep.
We appreciate the work you have done through this research. So one thing is that you have visually, it's not, you are not seeing the hand. That's the one part of the project. Right? The person who is being touched is not visually seeing the hand.
No, he's not seeing the hand.
So if that is the case, because it's practically you are going to see the person in front of you, going to have a handshake, going to see them. So possibly will that affect the feel, the visual?
No, actually, I mean this. As I said, by the time I finished this project, I moved to UK. But there were little more improvement scope on this. The one thing we only touched this part. So one of the claim from the reviewer was it would have been good because it's more of handshaking and all if you would have touch here. And then, but he did not claim that it is a bad idea. But he said in future you can do that. So we are trying to integrate many like visual component and this and to see how the effects were. But what I wanted to emphasize on that this was kind of a first study who took into consideration the real social impact of a prosthetic.
Seen through many surveys, that's one of the point I always say.
Yeah.
The amputee wants to wear the hand as his own hand.
Exactly. So that's what I'm saying. There are two things. One thing is the amputee wants his hand has to be his hand, true functionality, or the second is he wants that he should not be, realized by the other person that he is an amputee. So we were on the other part of the story to make sure that his hand is not being, receptive as a artificial hand, because that creates a social stigma for the amputee, which was very unique. Nobody was thinking in that direction.
Really good to know that research is moving towards society concerns.
Yeah, I mean that's what I said. I used to maintain a balance in my lab. Of course, your career is important for you, your family, and for IIT, and for me also. But then society is equally important because whatever instruments are there in my lab, they are just tax-paid money coming from the government or coming from the public. So we need to make sure that they are being served in a nice way. Any further questions? No? Okay, so what is the plan? So we need to wait a little more. By the time somebody can ask some question.
Sir, on the artistic part of research, is this equally to this kind of social part?
Yeah,
Artistic?
definitely. It has a lot of value. Okay. Good. So one thing you guys have to make sure, whatever you do your best for them. You know what is the best, so deliver for that. Don't compromise with the quality ever. It may take some time, but eventually it will be very helpful. So make sure that quality is not being compromised at any point of time, whether it is research, whether it is teaching, or whether it is anything. Because you will see that eventually you will also enjoy the same thing, and that trend of delivering the best quality will always be there, whether it's institute, whether it's a class, whether it's your family or whatever. Deliver the best for the quality, no compromise with that. Whatever happens, you do your best, which is very, very missing, but then you have to do that. So yeah, for MATLAB, unfortunately, we could not do it because of this system issue. But I think we'll plan sometimes. So maybe, I don't know, we'll plan something. So we'll meet again. Anyway, we have email ID of all the participants. So in future, whenever we are, or maybe he's conducting, definitely we are expecting that you all will be here, right? And you will bring your colleagues also, right? That's your duty, because we need to make sure that everybody gets the best. Once everybody gets the best, then it is the race of competition. But before that, there is no. We should not compete between two different kind of qualities. Once everybody gets the same thing, then let us compete, right? So next time we'll plan. So we are planning in various ways. We are also planning that this time it was very kind of tight schedule. So we'll also do this kind of like machine learning kind of thing, because my students also want to learn the machine learning. Unfortunately, we don't have this. I don't know who designed our course, but we don't have machine learning, which is very integral part of any biomedical engineering. So it's not there right now in our syllabus and our. But anyway, that's what I always want. So now I have somehow taken my time to teach them machine learning, even though it is not in the syllabus, which really stretch my daily life. But then I'm happy to deliver to them so that they are as equal as US counterpart to master's student. So we are also planning this way that we will have like signal processing 3 days. 1 day just signal processing theory from 0 to infinity, and then second day entire programming, third day entire programming with some case studies. Let us say I pick a IEEE transaction paper and I say, hey, I have the signal, just replicate all the figures which are given in the manuscript or IEEE paper. And then we do the same thing for machine learning. We pick the best paper in IEEE for machine learning. I teach you fundamental on the day one. Next day I teach you how to do it in MATLAB. And third day I give you a paper and say, hey, can you replicate this paper from morning to evening? Fine. C is very happy. So the frequency of moving your heads is very proportional to how